Hey guys. How are we going? Who's around? Morning, Ian. G'day. John, g'day. Yeah, I've been doing this for a few weeks. It's basically a onshape tutorial because there's a few people who said, hey, look, you seem reasonably proficient and I'd like to pick this up, but I don't have a clue where to start. I'm wondering if I'm getting voice. Can you hear me? Anyone hear me? Let me know. We'll do a voice check. Was a good day. You can't think and talk. I was just waiting for a few people to come in the room, actually. But hey, was I? It's past John's bedtime. He's not going to stay up for this. It's a bit late. I'll come and see you tomorrow, John. Just so you know, be around in the afternoon, maybe. Bring some stuff back and so forth. Anyway, John can hear me. That's excellent. Mark, good day. Yeah, I don't know where we're at. Is when we left, there was a few. We sort of bring some stuff. Right, I'll bring some stuff. Anything in particular you want me to bring? Let me know. Bring some 4X. I bought some 4X last week. Where were we? Where we left off last week was this little glue bottle. John's still thirsty. He drank a carton this week. That's all right. This little glue bottle we were working on. Right? Yeah. And just the bottle half without the lid. We didn't even look at the lid. That's pretty straightforward. We started with a we did some sketches and things, and then we went through to a glue bottle. After the live stream finished, I went through and put a label on this for the thumbnail, which is kind of cool. And I thought, well, maybe everyone wants to know how to do that. So down here in this corner, unfortunately, we've got this thing called Emma in it, but right in this corner there's a little plus. You're going to have to take my word for that. It's actually behind my laptop, which is why I'm looking back there like that. Let's move that around so that you can actually see. And that pops up a window like this, and we've got this thing called import right at the bottom. You can't see that either. I'm wondering if everyone can see my mouse. That's sort of... I think the mouse is a little bit better. I'm not sure how much better. But I did do some messing around and fix that. We might have to have a bit more of a play with it, but it's quite a bit bigger than it. I don't think it's a different color. I don't know if it's actually bigger than it was. I don't think that you can change the mouse pointer on Restream. There's an interesting thing. I don't think that happens because it's still a tiny little mouse, and I did make it quite a bit bigger. Anyway, at least it's purple, but I don't know if we did anything else. Anyway, we pop this up and click the import button. We can import pictures or anything else that we want into this diagram. And it's not going to show me that pop-up, but all I'm doing is important, basically, and it's uploading there a picture that I found on the internet for a glue label. It's giving me a notification to say it was uploaded. And we've got down here, we've got in one of these tabs, we've got a glue label. So my thought is put this on the actual bottle. So it's pretty straightforward. Now there's one of these tabs. We're going to go through these in a bit. I've got no idea where it is. Drop down. I think it's on the transform one. There we go. We've got wrap and we've got decal. If we select decal, we can select the image of... I work today. That's why we're a bit late getting started. I work today, so it was pretty... We can just... It gives us basically in this current document, it gives us a list of actual pictures we can put on. And we can select a face, just the same. If we click on face, we'll put on there. You can change the width, the height, and all those sort of things if you want to. You can use this to drag it up and down into position, or you can change the vertical shift. So if we type in here, if we wanted exactly 6 millimeters, if we wanted exactly 5 millimeters off the bottom of that panel, all we need is type in 5 and press enter, and it'll automatically put it in the right spot. So that's a pretty useful little function. It's cosmetic more than anything, but if you want to see how something looks with an actual glue label on it, there we go. So that's where we got up to. During the week, I've done quite a lot of work on the little truck, and quite a lot of work on the steering gear for the roller. And we might have a bit of a look at those things if anyone's really interested. But I thought we might make a lid for this bottle with a matching thread and a brush and all that sort of stuff. And have a bit of a look and see how it goes together. I might have a look at the gear and see how we've done that just while we're onto it. So we'll go back here to where basically to our menu. And we've got this out. That's the document we're just working in. We'll give it a second to sing. I don't know how laggy we are today. I hope it's not too bad. So there we go. They're starting to load. So this is the first one we looked at, the one we were looking at. And then here's the Foden FG S18, which I've been sort of doing a little bit of work on. And here's the Fowler jobs. If we click that, it'll open the last box that we were actually looking at. Or if we click it up here in this box up the top, or if we click this one here. If you click this, it'll give you the details over here on this side. You can put labels and who was created and who did the last job, who's been working on it. Description, all those sort of things in the thumbnail. If you click up here, on the text, then that opens a document. So that's how that works. I was hoping to get all this, but I only sort of really just got home, and I've got tomorrow off. So apologies for that. About a minute to load up. This document's getting a bit big because there's a lot of actual Fowler parts in this particular document, and it's not probably the best way to do it, is stick everything on a new tab in the actual document. But that's sort of how it evolved, because it's something I've been working on for years, and every time I do something, I just put it in here where I can find it. If we look at this, there's steering gears, steering and assembly drawing there. The steering worm, there's pump valve blanks, there's a pattern, so it's just a blank for a piece of gunmetal bar to pour it. Dowel pins, pump impeller stuff, there's a folder there, and we'll have a look at that in a minute. There's a folder that says motion covers. Now, there's enough information from 26 to make this worm with the radiuses and everything. So everything's there to do that. So I drew that up. I'm not sure why I've got one there that says steering worm with nothing in it. Steering gear new worm is that one. That's what I was looking for. So basically this profile was here, and if we get rid of that particular part and turn that on to show the sketch, this is what we started with on the center line through here. This orange one here is the center line, and then we've mapped up the profile, which has got a couple of curves in that one from this side here, which is this curve down here, basically, and one from this point here, which is this curve up the top. And of course there's a repeat over inch and a quarter, which is the circular pitch of the wheel. So 1/2 inch and 1/4 is 5/8, which is that distance from there to there, and then we've just mirrored the other side back in here, and that's given us basically an area there that that's closed because it's dark, and we can sweep that along a helix, which looks something like that. So basically we've swept that along the helix. Then left it as and made a drum and cut the helical sweep piece from the actual worm to get that. I don't know if that's making any sense. Am I making any sense tonight? I'm probably not. Everyone's gone quiet. Maybe I haven't. So put a keyway in it. The keyway is a very simple sketch. If we have a look at that. There it is. So all that is a circle with a cutout in it. It's very simple to put a keyway in. And when we've extruded that as a circle, it's basically shape. And then we've just revolved that around there. So that's how I did that. Bit of thinking, not really an out-of-the-box solution for this because it's older technology. The actual worm has not an involute curve, but it has a profile, and that's sort of, it's not a particularly easy thing to map out, but we've got a drawing and just basically copy that. Had a couple of goes at drawing this out because this is a bit of a challenge. If you draw a worm wheel out, it don't get results that are anything like this on any major CAD program. Joe and I had a bit of a mess with it on Inventor and also Fusion 360 with no more or less luck, to be honest. This is a fairly tricky thing to map out because it's got to have clearance, and it's got to have a helix on it as well. If we look at the top of that, you see it's got a very definite helix along it, a worm gear, which matches the worm. And that's swept along this curve here. So the clearance in underneath, or the gullet in here, which is an extra piece, is the same really. It's that sketch imported and then modified so that we've got this shape here, and that's actually swept along this particular curve to match the teeth. But before we did that, what we actually did was laid a worm in there. See if I can describe this without actually doing it. We laid a worm in there and then arrayed it round in a circle 17 times. So we've got 17 wheels around the blank, or 17 worm models around the blank, and then we removed one from the blank at a time. So what we've got is clearance on this tooth and this tooth and this tooth for your worm, all the way around. So there is clearance there. And if that makes any sense at all, that's how I did it anyway. I don't know if it does. I don't know. Yeah, this is failing to group or whatever, but that's sort of how I did that. And then I put this root in here with the curve in it against a profile, like on a helical profile there to match. So that's how I ended up with that. We've got to give you some idea. These two put together, and there's clearance there. And if we have a look at that, we can go to a section view. And probably an easy way is to look through this. And if there is interference here, these two will turn up with a red edge where they're touching or where they're overlap, if there's two separate parts in an assembly. So it's very useful for actually finding actual interference on parts like that. But I think we've got it right. We've used a gear. It's a bit more complicated, but we've used basically we've used fasten mates to fasten these into place. So we've fastened this particular gear onto this shaft, and we've fixed this shaft. There's a little symbol there that says the model one part is fixed, but I think it needs to be. I mean, I think there might be another answer to that, but this was getting late. This is fixed, and then this turns on that, and this one's fixed, and this turns on that. But there's a gear ratio between them with a automation. So if we sit down and animate that one, that's by right clicking on that. There's it says animate, and unfortunately we've got to change this to loop every time we do this, and we probably want a faster step, because the more steps the slower it goes. If it's going 300 steps around there, it's going to take a lot longer to do it than if it's going, say, 100. And then all we've got to do is click the button and everything works. So that's basically a gear animation. It's a little bit more complicated than a standard gear animation, but there's clearance all the way through. And if we have a look here, we can also select it, basically a section view. And can see that nothing's really touching there, which is rather nice. So that's a little bit more complicated as far as actual modeling. It's sort of next level stuff, but it's quite simple to do. And if you've got an interest in it, it's not a big deal to make something like that work. We close the section view. So that's the gear. That's what I was messing with. So we've got that sorted. We've actually started dividing this up, and we might have a bit of a look at this tomorrow night. I don't know, I've streamed, but I've started dividing this up into segments, which is how the pattern's going to look. So that's one tooth, basically, with all the profiles on it. So pretty happy with that, really. I don't think this will work, because if you've got a lot of these segments around in a circle, for example, if we were to use the circular array, which is under this one here, circular pattern tool, and pattern that one. We need an axis, which will do this curve here will do nicely for an axis, because it's all we need is a circle. And make 17 of them. Well, we've got the gear in 17 parts, but the problem with this is that once you get this in the sand or in real or whatever else, you can't actually pull these out because they're wider on the outside than they are in the middle. And for some reason, my cursor's gone back to white, so I don't know what the story is there. That's an interesting thing. It hasn't changed on my other screen, and if we move over there, I'm not sure why that is. It's still purple there, but it's not any bigger. If we move it off there, it's white again. So we're still working on that. Anyway, if you pull one of the, you can't pull these out from the inside. So they really, the whole thing needs to sort of be right on this line here when we do it. So what I want to do is make it basically an inner and have it lift off over the top of these, and then be able to pull these out of the mold one at a time and leave it in press sand. So that's what we're doing. Anyway, so that's what I've been working on there. And it's one of the things that yesterday and a couple of, well, when was I at Mark's? Sunday night and yesterday, I had a bit of a play with that. If we go back here to our main screen, wait for this to load. Come on, do our thing. You can click it up, or we can click it on here, and that'll load it. Move into the workspace. Is everyone still there? Let me know if it's glitching. It might be a bit. Might have to close this talking head thing and just go on to onshape itself. Same thing. We could turn this around, and it's much turning it around when there's actually a feature on one side. Click on this corner of the little square here, and that gives us an isometric view. So whichever one, if we click on that corner, it moves it that around to there. And if we click on this corner, it moves it back to there. Click on this corner and we can look underneath it like that. Top, front, left, and for some reason that's on the back, but there we go. And bottom, where we can see the actual text in the glass. So really, to do a lid for this, it's a bit difficult to see with the transparent lines. If we click on this, we might change the edit the appearance of this. And change the transparency completely so we don't see inside it. We might leave it at that for a bit. It's a little bit easier to look at. So that's where we got to. What we need, and these little testers bottles, glue bottles, are all the same. There's various different ones, but they're all the same shape. Basically, they go on the same shelf. I'm not going to open these because I don't know which is the best one to spill. It's a really good question. But they've got a brush inside them, a very fine brush on this one for glue. They've got a seal inside, neoprene seal, stop the stuff evaporating. And it's got a texture. If you can hear my fingernail on there, but it's got a texture. If we look at it, it's basically a straight knurl or a spline around it. And this one's translucent green. For example, this one here has got a grey solid lid. This one here has got a black lid. Not sure how long I'm going to handle having the actual lid off this without getting a headache. But this is straightforward little piece, I think. So first thing, we want to put this on a new part studio. So if we start a part studio, it says part studio 1. We right click that and rename it to bottle lid. Like so. And I guess the main features that we can see are from the top. So we want the outside diameter. We've got a vernier here. It's actually 26 mil. Actual lid on the bottle is quite a lot bigger than we drew anyway. But let's make this to drawings and then we'll change the bottle to later. This is 26 mil, and this here is this way is, what are we, 23 mil, something like that. There's a recess in the top that's about, what are we, 6 mil deep, something like that. And this piece, the membrane that goes through that goes through, it looks to be, with this translucent lid, you can see inside it there, looks to be about 3 mil. And there's a little retainer in there. It's a little bit more complicated than that. It's a little retainer in there for the neoprene seal as well. So let's just start with some basics. Start with a sketch. Sketch plane, we're going to use the top one. Circle. And some of these we can put straight in. 26. We'll put another one on there. Just looking at that, that looks to be about 24, 22 mil. It looks like, what do we got here? It's probably 1.5 millimeters on each side. Let's say 23. And we can go ahead, straight ahead on that sketch. And we can extrude it. What do you mean by that, Peter? Interested to hear your feedback on that. what we want to do is extrude this each side of the center line, because we want to make all these features on the inside on the actual plane, and that way we can make that work much easier to draw all these features and sketches on the actual plane rather than try and measure it all up or offset it or whatever we're going to do. So that looks like it's about 9 millimeters that way. Love some feedback on this, because I mean, it's not a particularly exciting project, but we're going to end up with something that actually looks good and looks like part of it. We want a second end position, so if we tick this box down here, it'll put a second end position. So out the back of the back of the plane that we drew on or sketched on, it'll actually give us a second end position. And that looks to be about 15 millimeters. Now, these have drop down menus here, and there's things we can do. This is just a blind extrusion, so it just goes out parallel and perpendicular to the actual sketch. So if you want a 15 millimeter extrusion of a pipe off a sketch, it'll give you a nice square end on it. This second one is up to next, which means if you've got another part over here, it'll automatically sketch this up to the next part. So you don't have to worry about measurements or messing around and seeing if you've got it lined up or anything else. Up to the face, I believe that up to next will also just bring it up to the next sketch plane. Up to face will actually, if you've got a fancy curved face in here, you can extrude this up to the face and it'll give you the same curve on the end of the extrusion. Up to part, up to vertex, and through all. So if you want something that will stick out through, especially if you're removing parts from others, you want something that'll go all the way through. That's the best one. Up to vertex, which is up to the furthest most point, I think. And up to part, which means you can actually select a part. If you've got another part in here and another part up here, you can select this part and it'll draw it out through there, through that part up to that one. So that's quite useful to know. There's also other things, like you can make this symmetric, which gives you the same distance each side of your sketch, half of this measurement. So if you make this 9 millimeter and make this symmetric, it'll give you 4.5 millimeters each side of the sketch. You can also put a draft on it. If you click that button, it'll actually show you a draft. If we're not going to go ahead with that, but if we want to put, say, a 20-degree draft on it, that gives us a shape like that. And we can press this button and it'll actually make it the other way. It won't, because 20 degrees is not going to leave much left. But that's how that works. And you can do exactly the same thing for the other end. So that's our part. And we've just got a new part because there's only one there. And we can rename that if we want to too. So that's a good start on the bottle. If we do another sketch, if you select the bottom plane rather than the top plane, it's exactly the same plane, but it'll point your extrusions in the opposite direction. So that's fun. We might do that, Peter. Might do that for next week. So I see what you mean. We might actually do that. Sketch plane on here. It says top plane, but we're drawing it from the bottom. And same thing, we've just gone halfway across there so that it's actually, we know it's going to be part of, it's not going to, it's like having two pieces of plasticine and smashing them together. There's no actual parting line. So if there's an overlap, we know that they're going to join together nicely. If we just press escape, we get rid of the size or the measurement completely. So it's not actually on that sketch. And same deal. If we click extrude, that'll extrude the center out way past what we need. I think it's about 2 millimeters. And it automatically selects add here. We can click new, and that'll change the color so we actually see that it's a separate part. If we click add, it'll make it the right color, as same as this. It'll add it straight in. There we go. Now there's a couple of features on the bottom on the inside of this. Very difficult to see on the actual one I'm copying. But what there is, if we put a sketch on this face with a couple of circles, what we've got, let's call it 16. And another one here like this, which is, we'll call this one 14 for purposes of being simple. And there's a retained neoprene seal in place. I don't know if we can actually see that, the white seal. But it's got a ring to hold it in the right spot. Same deal, we just extrude it out. You can be pedantic about measurements. And there's a brush, which is probably 35 mil long. So we'll put another sketch on here. Looking at that, that's just a tube that's actually attached to this by a spigot that sticks out. So I think, yeah, this peels off. So you've got two separate pieces. All we've got to do is make a shaft for that to stick on. So we'll do the same thing. Come on, do the thing. There we go. Select the center. There's just a lot of, let's call this 1.8 for example. All this is a lot of circles. That's all we're making all this out of is a lot of circles and stretching them out. I reckon it's about 12 mil. Like so. Now this wants a fillet on it or a radius. We'll use this tool. And put a fillet on it. You can change all the parameters, but this was already set so that that's about where it should be. So there's your lid. It's missing one thing, and that's a thread. Now, this thread, if we put it across onto our bottle, is actually a different dimension. If we go down here to this little measuring tape in the corner behind my face, and it gives us a little pop-up and show measurement details. Select entities to measure. If we click on that, it says it's 23 millimeters diameter. So I'm guessing that's the thread that we that's the diameter of the thread we probably want. Up here on the feature script and drop down, you've got a couple of options, but here there's a thread creator, and that's what we used last time. And we can pick up basically we select the face we want to thread. And it will to start thread from memory. I'm guessing it was probably ISO thread. But while we're looking at this, and we're thinking, what thread that? What did we actually use? Because we really haven't got a clue. We can go straight back here to the bottle while that's still open. As the variable that I've put in, and we'll have a look at that in a minute. But the thread was actually M18, 3 millimeter. Now that's not, will it work? Don't think it will. Doesn't look like it probably will. So we're going to have to, what the best way probably to do this is to go back to the lid and make a thread that looks like it's going to work. That's probably not it. Is everyone asleep yet? I don't know if we're actually covering anything that we need to be covering or what's happening, but we'll make this little model and then we might have a look at some buttons. We go 1.5 where that looks sort of half reasonable. And it's a 2-start thread. It says fully threaded, and we don't really want it fully threaded. We want number of turns. Let's give us 2 turns out from the bottom there. I don't think that's enough. Let's go. I think that does. that gives us a soft start, the lead-in pitches. So it gives us a gradual thread. So it makes it easy to start. That looks pretty good. So we've got 4 turns, 2 lead-in pitches, and the number of starts is 2. Looks pretty good. Change the colour of that pretty straightforward, so you can tell all the bits apart. And that's the lid. Now the 2 threads don't match together because they're not even close to the same. If we have a look at this bottle, it's a little bit, we sort of guessed it. I've put in here that the thread equals 18 millimeters. And if we go over here to this appearance panel here, or the configuration panel, or the custom tables, where the variable table is what we want, and open that, it gives us a table here, and it gives us a value. Now, if we change that thread value, I think it'll work in a minute. Come on. There we go. To 23 millimeters, which is what it needs to be. Come on, click on there. Here we go. We can change it. We click that. We can change the value to 23 millimeters. If we do that, it's a double click on this here. That moves everything to 23 millimeters. So what we've got here is a table of actual features or actual measurements. So this one's called a thread, and if we tag a measurement as hashtag thread, use the actual measurement, that will automatically set that up. If we go to the lid here, and this sketch, which was sketch 1, this is 23. But what we can do is call that one hashtag thread. And that gives us the same variable in this chart here. So if we change, or we should be that if we change that thread and change that dimension on the chart, then this should change all the way across. So there we go. Let's change that. We've still got a different thread. If we close this, we can change sketch. It looks a bit sort of small, so let's edit sketch 2. We change that to 44 millimeters. To change our proportions a bit. There we go. That looks a bit more like the bottle. So this thread's still too coarse. We need to change that. .5. 4 turns we said. To start. 2 lead-in pits. There we go. So what we should have, whether it's right or not, is the same thread on the bottle as that we have got on the lid. And there was some discussion last week about how you make a table of variables, and that's it there. And we've only got one variable in there, it's the thread diameter. But we can put as many as we like, and if you just want to change one of the variables, which is done by double clicking on there, then you can change the thread. If we think that thread's feels a bit big, we can just double click that and change it. Not a difficult thing. I think that's probably all right. I think the two will probably screw together very nicely. Next job before we make any more bits is probably to go here to our assembly. From there we can insert the parts in. We insert the bottling, and that'll put it exactly right on our origin point, the same as the other. We can move this around. See, once you've moved off there, that moves it around. But if you're back on here, that'll put it straight on the origin point. So we click that, and that puts a bottle in. Now we need to insert to a lid. There, and here somewhere there is a screw relation. Before we do that, we need to put a cylindrical mate, which is that one. So what we're going to do is put a mate in, or basically a reference point, which is a little star-shaped circle. There's all different sorts of them. You can have a slider mate, or like if you want 2 pieces to slide together, or you can get a planar mate, which means that they'll slide all over the plate, or you could have basically a revolute mate, which turns, or a fasten mate, which is lock solid, a spherical mate, so it turns like a ball joint, a tangent mate, so that it's actually 2 surfaces touch together and they keep touching together. And it's just a matter of selecting the point that you want to put it. So the center point of there, it's a good start. And what that's done is put the two things together. But if we get this bottle and we click fix on this one, like we looked at before, right click it and select fix, then we can't drag and drop that. We can't move it around. It's fixed. This one we can though. See, this is attached on that plane. So basically we can move it up and down. If we use a screw relation, on the cylindrical mate, and we set our distance per revolution because it's 1.5, we said, wasn't it? 1.5 millimeters the thread. And click that. Then we can screw, let's have a look, we can screw, it should off, I don't know if you can see that. It's gonna, we've got 5 people watching. Very difficult to tell because there's no texture on there, but that screws up and down. We can animate that. Anyway, sometimes it takes a bit of messing around with, and we probably haven't really got time with it, but we can animate that thread to screw up and down. You can't see it because there's no actual, it needs marks on the lid. So let's go back and do that. This one has a knurl on the outside. There's a couple of ways you can do that. Probably the nicest and easiest way, if we look at this, is to start with a new sketch. And to draw out see, we've got a dotted line appear there. I don't know if you can see that, which gives us basically a restraint on the center there. If we use a center point rectangle, we can draw out a rectangle like that. Something like that, exactly halfway over the edge. If we go up here to circular pattern, we can array that. And because we're on the origin point, that automatically puts the origin point there, and it gives us 3 to start with. Put 70 is too many. 55 still too many. Let's go 48. And it's just a matter of extruding those, selecting remove, sketch 5, and merge scope part 1. Let's have a look at this. It's pretty much all the way down except for that little piece on their bottom. So let's go 26 millimeters. 27. There we go. If we animate that now, we're sorted. We need to set up some limits on that. A matter of clicking that button. Now, our limit is there, and let's say 30 millimeters up. I don't know if you see that, but we're actually unscrewing that bottle. And I think that's just lag because I'm doing so many things with the internet. I don't know if you can see that actually turning as we pull it off and on, but that's how it works. So there we go. We've got a bottle lid. There's still a brush and another part studio for that. Is a pretty simple little job. We'll call that a brush so we know what we're talking about. Now, this is automatically put this over behind the parts assembly because that's what we're working on when we put new parts when we put a new parts studio in. Very easy to drag this back. We've got another one here that's sort of a bit complicated or not part of it. So what we can do is create a folder. And we call this one bottle. Then we can drag all these bits into the folder. Just the same as any other file system. And they should all automatically update. So if we open that, all these things are inside the folder. So they're easy to find and we know exactly what's there. We've got this one's brush. It's telling me I've got a poor connection. I'm probably going to close my talking head here a bit. We've gone an hour, so it's easy on this. I'm just going to mess around and make this quickly. I don't know how laggy we actually are, but we did struggle at last little animation. Now, this was 1.8, wasn't it? 1.8. And I reckon it's about 3.5 on the outside. We'll just do this draw. If we extrude that, we call it an inch long, 25 millimeters. If you do want to work in inches, it's very easy to change halfway through and work back to inches. It's not something you need to redraw right from the start and set up a whole page. You can just go up here to the menu, drop it down and select units and change it to inches, and everything will automatically change over. Edit appearance, this is white. Or as white as we're going to get it. We can mix that up and we can go for like a really white. But it's going to give you a shadow, so it's really a grey. That's that bit done. Assembly. Same deal. All we want to do is use a mate. So we're just going to use a fasten mate because it's fixed. And connectors. So we connect that. On the end of there. We've got to import it first. That's a bit poor. Import that. Somewhere where we can see it. And then use a fasten mate. And we might have to flip the direction there because we've used the wrong end. And there's our brush stroke. Now, because they're fastened together, what happens is, when we move this down and screw this in place, that'll screw with it because it's actually part of it. And it'll turn with it. So that's the brush and the lid. Anyway, it needs a seal still, and that's a very straightforward thing. Certainly make a seal that goes in there nicely, that seals on the top of the bottle. If anyone's interested, I would, if I was doing it, I'd start with a new part studio. Rename it, just same. Seal. Top plane, so we don't have to. And it doesn't really matter. If you want to draw that on the front plane, it's not a big deal. It's the wrong way around when you import it. So there's a bit more messing around. But if you want to do that on the front plane, we'll see what happens. 22 millimeters outside, let's call it. So it goes in there. and I think inside was 16, I think, was from memory. Is that what we did? 16 millimeters? That's the dimensions of the seal, and all we've got to do is extrude that. And it automatically takes a default of 25 millimeters. You can change that in the settings. So if you want something, if you think that's a real pain, and all the work you do is just extrude in 10 millimeters, you can change that to default, so you've only got to change it sometimes. But let's call this 0.6 millimeters thick. There you go. Same deal. We can change it to a custom white. Oh, I would say we want to put a red seal in it. So there we go. The same thing, really. We've got this bottle here, and we can turn that off if that's in the way. So if we go up there, we can just close the eye off, and we can't actually see it. If we insert the seal, because we did it on the front face, it won't be lined up. There you go. See? So a fasten mate or a Revolute mate or whatever you want to use, we just select our mate connectors. If we select that circle, it'll give us a mate connector in the center of it. So that's the point that we're aligning. And same there. Because it's pointing up rather than down. And there's a seal in place. So we've got a pretty cool little bottle lid. There's no writing or anything on it. And it's got a little brush here, which is basically a brush. And there's various ways we could do that. But we'll leave that off for now. Anyway, so that's straightforward. I mean, you can come and go as you like, guys, because it is late, and I understand that. But what we were going to do is have a look at some of these buttons, which we... make a sketch, something like that. Some of these extrusion buttons, right? We've got the extrude button, which we've used. That was it, Peter. That was it. I could get a vernier out and measure all that, but that's what you got. She'll be right. If it looks eye sweet, it probably is. It's not a bad looking thing, and you can go through afterwards and put all your dimensions in like we did. So you just make something that looks right and then measure it and change your dimensions. The extrude button we've used. The revolve button I think we've used too. If we want to revolve this square around that line, for example. Face it, we can just click face it and stretch as to revolve, which is that. And the revolve axis on this line. And that'll give us basically a ring. It stretches that round in a circle. So that's how that works. That's straightforward. Play around with it when you're messing with it, but it's very simple. We can select full circle or one direction or symmetric or two directions. I think we've covered this pretty well last week, but you can do what basically do what you want. You can stretch this around, or you can put in an actual measurement. If we click this as a solid or a surface, that will just revolve the edges, you see. Now that doesn't actually have any mass. It's a guideline or a construction line, if you like. Doing a surface like that doesn't have any mass. There's no thickness to that. So what we can do there is extrude the surface or sketch on the surface, but it doesn't actually have any mass. We have this function here called thin, which puts a thin piece out, a thickness piece. You can make one of those lines 2 millimeters thick and revolve it. And revolve and basically set this up each side. So one of these, the thickness one is giving you the measurement from that line down, and thickness 2 is giving it from that line up. If we do this and it's on the wrong side, we can also just click this line here, which will flip it and put it on the other side. So that's simple. The next one's a sweep function. Basically, that puts a shape along a line. If we go here and put a sketch in here, and we're going to use something we haven't really looked at very much, which is a spline. From that point, like so. Then we can use the spline function, and if we want to sweep that along the spline, that might do it or it might not. Let's have a look. The thing about CAD is that you don't have to be super precise. You can put whatever information you like into it, you know, either way. This is struggling a bit with this. Because you've got inks. Let's see if red shape. So it basically is an error. Struggling with it a bit. If we go to this sketch, highlight that, and it highlights up here. I can't remember which sketch this was. So if we highlight a part of that sketch, then up here on the function, the features menu, it highlights that sketch. So then we can just go to it and edit it. And what we're going to do is put a dimension on here. That's 47 millimeters. Let's make it 7. And job's done. Because there's less kinks in there and it doesn't overlap on itself, when we sweep that curve or that circle along the sweep path there, It has a lot less thinking, and it actually says grey, so it all works. But that's sort of how that works. There are several ways you can do this. There is a line that will go in a three-dimensional function. So if you're putting a, say, for example, you want to run a wiring loom or a power cord, or you want to bend something up around in all different directions. If you want to make a wire chair frame or something like that, there is a line that will go in all directions, and you can extrude along that. We'll look at that at some point. That's a fairly new feature. So that's what sweep does. This one's loft. And that sort of does a similar thing. If we loft that shape, we can loft it along a path. If we want to loft it along, say, that path. It's got actually a bit of face to loft that. Not something I do very often, so I have to sit down and mess around with that a bit. But what it will do is give you basically a shape that introduces or meshes with another shape. So if, for example, we're something that's been that needs that, what have I got here that we can have a look at? It's actually a lofted shape. Good question. Basically pulls the shape out and makes it a different, it gives you a different state on the other end. So you can put a curve on it, or you can stretch it out, or basically for two connections. And this is thicken. That's simple. So it's the same as an extrude function, but if you can stretch that shape out easily without actually sitting down and making another shape and extruding it. So all that's done is made that bigger. It doesn't give you any other options. It's just made that particular shape thicker by however many millimeter you put in. So if we click that, that's just giving us a lighter, thicker shape. So that's all that does, is a stretch out tool. It's got a drop down arrow and there's enclose. Now, if you've got two shapes that you think might, let's do it like this. This shape here on this end of this curve, and this shape here. is that not working? But that should provide it will provide a breach. Gosh, I'm tired tonight. Sorry, guys. It shouldn't work on Tuesdays. But basically, it'll give you a... I've got that wrong. What you've got, let's start this again. It's nearly time to finish, I think. Let's sketch something up. If we... There we go. Say we extrude that, and we extrude it as a surface, which gives us a little cylinder with no ends in it. There you go. Then if we use enclose, it's made a liar out of me. No, it's getting a bit late. There's James. It's getting a bit late. But these next buttons are pretty straightforward. There's a fillet and there's a face blend. So if you want to blend two odd faces together, it'll put a blend across two lines of two parts that match it together. There's a chamfer function. There's a draft function. If you've got a box and you cut out a shell and you want a parting line on it with a draft on each side, you can designate a parting line and it'll put a draft on it so that you, for casting pattern or for a die. This one will give us a rib. This will give us a shell. If we... Let's have a look at them. We know how to operate those pretty well. Let's select solid there. So we've got a solid drum. If we use this little shell function, we can remove this function, this face, and it'll automatically hollow it out to a certain thickness. So no matter what shape it is, and that's what we used on the bottle, we use the shell, and that gives us a uniform thickness all the way through the shape and a hollow. This is a hole function. This one here is hole. Now, this is more an engineering thing. I want to put it in here. We've got all sorts of things we can choose. We can choose a drilled hole with a pointed bottom, or a clearance hole, or a tapped hole. And we can choose precisions and tolerances. We can probably choose, if we select tapped, then it gives us the option to choose threads as well. So if we want to put tapped holes in something, we can also set up a table with basically a hole function on it, and then all we've got to do is type hashtag hole, and it'll put the same hole wherever you make that designation. So that's a fairly useful thing. It's also got simple holes. It's got counterbore holes, countersunk holes. So it's got counterbores, countersinks, all those sort of things. So it's a countersunk. Let's just change to countersunk there. So that's pretty. So rather than sketching out all your holes and then extruding them and making chamfers on the ends of them, you can just mark out the holes and select the right functions, and it'll put threaded tapped countersink holes in there in one operation. This is the external thread, which is really only a visual thread. If we put a thread on there, it doesn't look anywhere as nice as the one on our bottle. I think my connection's not real good tonight either. Pattern and square pattern and curve pattern and all those things. If you've got a spline and you want to put objects along the spline, that's what that's for. Then you've got mirror and Boolean, which has got different features to extrude. So we might look into that at some point, probably next week. Anyway, we didn't touch on that much, but we did make a bottle for the lid, which if anyone's interested is there. And we've got a bottle there as well. A quality vintage label on it. And a screw on lid. There's no limits on that yet, so it's just screws down past. But you can set up a limit so that touches on nicely on the seal underneath, and then we know that it's right down. And you can animate that to come on and off, so that it'll screw, unscrew, and screw on. So that's what we've done tonight. Thanks heaps for tuning in. I don't know if I think everyone's sort of completely over this. Maybe it was a good idea that's not actually going to go anywhere. Whether people are actually learning stuff or what, I don't know. It's getting a bit late, and the stream tends to get a bit long, and I'm sorry, guys. But this is something I find is actually relaxing and fun. So I sit down, I'm here for a couple of hours, which is not such a good thing, perhaps. But anyway, I'm going to call it. Thanks heaps, guys, for tuning in and a little bit of support. I don't know who else is watching. We've got 5 people. I've got Peter there, and we've got James. Looking, we've probably still got Mark. Poor Mark. John Pettit went to bed. We could have Ian Matthews. And we could have Wazza. Peter's still there. Anyway, that's sort of how fairly simple it is to make something that's a pretty decent model, really, in onshape without a lot of effort. Let's start with a box and round some corners off. And honestly, we're not that far off. Hold it on the right angle there. Probably. There we go. Something like that. We're probably not that far off actually being how that works. So probably going forward, if we're going to build something, we might as well start on a project or actually make something. I'd like to put it at a bit of a vote. Anyone who's watching this, if anyone's got a good idea of something that we could actually make, that's not just a boring bottle that someone else has mass produced in it, at a crazy amount. There's probably something that's quite useful that we could 3D print or that we could translate into an actual object that we can make. And we're probably at that level that we can do that. I don't feel tonight like I've explained very much because it's kind of I work today and it's been a fairly busy day, and I'm a little bit more burnt than I usually am on a Tuesday. But that's how that is. So it's a good program. It's pretty consistent. It's very interesting when we were messing with the gears and the animation to see that Inventor or Fusion 360 didn't handle the worm and gears any better than this does. And in some ways, probably a little bit worse. So that was an interesting exercise for me to see that. We'll have a look at the worm, as Peter's been here all along. I don't know who else has. These are all, basically they all are, but whether they actually get from this actual drawing phase to an actual I'm going to put a link to the bottle. There's the gear. The bottle drawing, and probably the gear drawing, if anyone wants a bit of a look at that, in the description on the video on YouTube. So if anyone wants to click on, you can copy it and have a play with it, or you can just have a look around it as a guest in Onshape just by clicking the link. You don't need really very much information or sign in even to do that. If you want to look around, and you'll be able to basically you'll be able to sort of see where we're doing and how it all works, and see the animation for yourself without my very restricted internet slowing it down. So that's where I'm at. I've got tomorrow off. Live stream tomorrow and probably will be much better than this. I think it might be a little bit more put together for that. We still live stream as normal from the workshop on Wednesday nights. Thanks heaps for tuning in. Really appreciate your input. If you've got any questions, hit me up. Absolutely. And if you've got a project you're working on or you've decided to start with this program, don't be afraid to ask about it, because very happy to step in and give you some one-on-one or an idea or add insight on how I would probably do something if you get stuck. So that's where we're at. But get in and mess around and have a play with it, because you can't really go any wrong as soon as you delete stuff. Anyway, I'm out. Thanks, guys. Really appreciate it. I'll be on Discord for a bit because I probably don't really have to go to bed straight away. And more soon, guys. Thanks for watching.